Hello and welcome back, my friends. It's that time. It's quiz review time. Got some tough questions coming up. I'm not going to take the time to do this, but you need to be able to redraw this in the space here. I don't like the way it's broken up. Maybe I need to redo that, but I need you to be able to recreate those. The only thing I'll say is I usually pick a spot and then just start counting, right? Down 1, 2, 3, 4. So I'd go to the next page, just pick a spot to start and go down 1, 2, 3, 4. And then I just keep counting from that location. It's back 2 from that spot. It's back 1 from that spot. So from that location, I know it's going to go back 2. And I know it's going to go back 1. One spot over goes down 4, and I just keep drawing from there, right? One spot over, I know it goes down 4. Over here, I know it goes down 4. So you can keep doing. I'm not going to make that whole thing. All right. And I got a little bit of the sniffles, a little bit of a cough. I apologize. It's just going to happen, my friends. Hopefully I get a lot better super soon. All right. The next one says, if you cut the length of a rectangle in half, what's the effect on its area? Well, it's going to be, if you cut one dimension in half, then the area is going to be cut in half. If you cut both dimensions in half, then the area would be 1/4. Just to be clear, area equals length times width. That's one of the formulas. And it says if you cut the length in half, that means the length would be half the size times the width. Well, if you factor out length times width, right, factor those out or pull those to the front, what do you have left over? You still have a times 1/2. So length times width, that's the original area times 1/2. So the area is 0.5 times the original would be the answer there. Yes. Number 3, the base of a parallelogram is 1/3 the original, but the height is multiplied by 12. Well, what is times 1/3 times 12? It's going to be times 4. If you plug it into the formula, base times height, well, if the base is 1/3 the original, and the height is 12 times the original, and I pull out BH, right? If I pull the B out, pull the H out, what am I left with? I'm left with times 1/3 times 12. Well, what is times 1/3 times 12? It is times 4. So it is the original area times 4. That's what happens there. So it is 4 times bigger. The next question we want to know, so we're on number 4 here. It asks us, what shape would this be? Well, if I count the sides, 1, 2, 3, 4, 5, 6, that's 6 of them. So that's a hexagon. And then these are triangles, and there's only one hexagon. So it's got to be a hexagonal pyramid. Nailed it. And then where would the red edge, red, line up with? It's going to be blue, green, or orange. Where would it go if you folded this together? Well, blue would line up here. As I wrap it around, green would line up here. As I keep wrapping around, the orange would eventually line up there. So it would be red lines up with orange if I were to fold that together. Okay, so we're on number 5. It says, find the area of the rhombus if AC equals 20. The angle ABC is 80. So rhombus properties, we learned them last chapter. The diagonals are perpendicular and they cut the vertices in half. So we know that that's going to be a right angle. If AC is 20, we know it's going to split it into 10 and 10. And we know it cuts this corner into 40 and 40, and I need that number. So I'm going to do some trig. What I'm working on here, if I highlight it, we have a green right triangle here. Kind of line that up. I'm going to work on this triangle right here, this green triangle. That's the one I want. And what do I have? I have a 40, I have a 10. We know this is 90, so it's a triggy problem. We got to get triggy with it. So this would be the tangent of 40 equals 10 over x. So that value is 10 over the tangent of 40. Well, that is half the diagonal. You do need to know the rhombus formula. The area of a rhombus is D1 times D2 divided by 2. Well, they told us D1, right? This distance all the way across is 20, so that's 20. Now, what would be D2? If x is half of the way, I want to go the full way. The entire way would be 20 over tan 40. All that divided by 2. So I'm going to type that into my calculator, make sure I get the answer I have here. I have 20 times 20 over tan 40. All of that divided by 2, and I get 238.351. And that checks out. So just real quick, look at the calculator screen. Oh, it's all covered up. Give me just a second. There we go. There we go. Boom. That's what we're looking at. 238.351 if we round to the nearest thousandths. Perfect. Perfect. All right. Next little spot. Next question. This one's going to be a little bit harder to do for sure. All right. It says this is a level 4. Yep. We got a lot going on. All right, team. So take a look. I'm going to highlight it in green. Highlight it in green. Look at all of this. Boom. And these are some of my former students on here. They've graduated now, but they're some of the best. You know who you are. So I've got this shape. And is it the same shape all the way throughout from the front to the back? Yes. If it smells like a prism, if it looks like a prism, you treat it like a prism. So this green shape is what I want to work on. I'm going to pull it down here. I'll make it a little bit smaller so I can work on it. What are the pieces? What can I do to this base? I know that the bottom is 19. I know that this little part is 5. I know that this is 13 and 13. They tell us, look back here, if this is 4, this will be 4 up front. So this little part's going to be 4. Back is 11, so this is going to be 11 in the front. Based off what we have here, this would be 11 over there as well. And then they have a little dotted line, or like we cut that off, and they tell us that this distance right here is 12. All right. So I need to treat it like a prism. I'm going to write the formula down. A prism is pH plus 2B. I need P, I need B, and I need H. Well, H is the distance between the bases. So I know H. H is how far is it from front to back. The distance between the bases is 9. This formula is for this figure. Remember, heights are what we get confused real often. The height of this figure is 9. If I'm considering the front and the back of the bases, the height is 9. So I need P, the perimeter. Well, the perimeter is the distance around the shape. I'm going to add all those numbers. The perimeter is going to be, start at the bottom, 19 plus 11 plus 4 plus 13 plus 13 plus 5 plus 11. So I'm going to type all that in. We have 19 plus 11 plus 4 plus 13 plus 13 plus 5 plus 11. And I get 76. So my perimeter is 76. Okay. And then I'm going to find the area of the base. That might be a little bit more work. Area is usually more work, but we'll see. So the area of the base would be the area of this triangle plus the area of the rectangle. Let me think about that triangle for a second. A triangle area is 1/2 base times height. I need to know how long this is. I know the height's 12, right? They told us that's a right angle. Well, that's going to be a 5, 12, 13. And because both sides are 13, both parts are going to be 5. That's a triple. That's Pythagorean theorem. So for the triangle part, it's going to be 1/2 times 10 times 12. Don't do half of 5. 5 is already half. Remember, we don't do half of half. It's half the base, 10, times the height, 12. So the triangle is going to be 60. All right, and then we have the rectangle part. So the rectangle's area, is one side times the other. I don't remember how it goes. But it's length times width, or base times height, or no matter how you organize it, it's 11 times 19. So that's going to be what, 201? Let me type it in. I don't know. 11 times 19. Feels like it's 201. Don't want to be wrong, though. 209. Oh, duh. So that's going to be 209. And so then you add those together and you get 269 as the area of the base. And finally, the final answer, we plug it into the surface area formula, is going to be 76 times 9 plus 2 times 269. And I don't feel like, oh, I erased something there. I don't feel like doing that in my head, but 76 times 9 plus 2 times 269, I got 1222. 1222. I don't know if I accidentally erased it or I don't know where it went. But there we go. Hopefully that's the right answer. I should double check. I try to keep my answers correct. And that is the answer I got. Yes. Okay. Moving on. Number 7. A regular polygon. Ooh, the second I see that, I'm drawing my right triangle. It has 36 sides. So I'm going to do 360 divided by 72. Well, 360 divided by 36 is 10, divided by 2 is 5. So that's going to be 5. That is the angle at the top. I'm not doing a full lesson on this, guys. There's 36 sides, which means there's 72 of these triangles. And we know that the center adds up to 180, so we know that that spot has to be 5. The apothem has a length of 8, and I need this side. Hopefully we're getting better at trig. I'm just going to go straight to the answer. You can show your work if you need to, but this is going to be 8 times the tangent of 5. So we could use the formula 1/2 AP, or we could do 1/2 times base times height times 72 of them. And that's what I'm going to do. So we have 64 times 36. I'm going to type it in. 64 times 36. We have 2304 times the tangent of 5. And I get 201.574. Perfect. Love it. Let's make sure we're good at those. Find the surface area of the figure. Find the first surface area, oh my goodness, of the figure. There's a lot of work to happen here. So I'm going to do my best to explain. So we have a cube. Now, I'm going to draw a square. I'm just going to try to explain this, guys. I know it's hard. It's hard to explain. So I know it's hard to understand. So I'm going to draw, the net of a cube. So hopefully we can picture, hey, what I'm drawing here would fold into a cube. So if I folded that together, yes, I get that cube. I'm going to come up with a plan. My plan is going to be the total of the cube. Now let's understand, what is the total of the cube? When I do the total of the cube, I'm getting the area of every surface of the cube. It's surface area. We're not talking about anything on the inside. So I'm getting the area of all of that, guys. That would be the total of the cube. But we have a problem. This circle is not there. On my net, that would be over here. There's a circle on this surface that when I do the total of the cube, I need to make sure I account for the fact that that circle is gone. It's a hole. I need to subtract that circle to account for the fact that that circle is gone. And then what happens is I get this inside lateral surface, this edge, right? This border, that wall. What shape is that wall as you spin around on the inside? It's the inside lateral, and it would be a cone. Now, the lateral of a cone, it looks funky. It looks kind of like this. So then I have to add that. I need all of this. That's the lateral part of a cone. It has no base, right? Again, that cone does not have a base. But if I said to paint this object, you would have to paint that inside wall or that inside lateral. So this is my plan. Now, what are these formulas? Cube is just 6s squared. That's the shortcut. I don't know if I even talked about that in class. But one square is s squared, and there are 6 of them. Minus the circle. Well, a circle is pi r squared. And then plus the lateral of a cone. A cone is pi r l. You need to know that IRL. All right. So then we need these pieces. Well, we know that the side of the cone is 6, so we can do the cone. That's going to be 6 times 6 squared. That's going to be 216 if I know my math. And my pencil stopped working. I love this. I got to shake it, get that ink to the bottom. Okay, it's not working. Well, either way, I'm going to check my work anyway. 6 times 6 squared is 216, and it's back. Nice. And I was right. It's 216. Minus pi r squared. Pi, the radius, well, if the diameter is 4, then the radius is going to be 2. So that's going to be minus 4 pi. And then pi RL, well, we know the radius is 2 still, but we need L. So take a look. There's a triangle. Let's go gold. There's a triangle here, and I need to work on that triangle. I'm going to draw it up here. We have a right triangle. Ah! That was scary. We have a right triangle formed by the radius, the height, and I need the slant height. Well, I would do, good practice would be divide by 2. Divide by 2, that'd be 9 plus 1 is root 10. So if we divided by 2, we got to multiply the 2 back in. So the slant height is 2 root 10. So that's going to be pi times the radius. Oh, we already did that. That's going to be times 2 root 10. Now, if you have a calculator, of course, you can just type it in. But we got to learn how to do good math. But that's going to be 4 pi root 10. And actually, those are unlike terms. So that's just the answer. You would just leave it like that. But they did ask us to round it. Let me type it in to make sure I got the right stuff. I have 216 minus 4 pi plus 4 pi root 10. And I get 243.2 when I round it. Yes. All right. Sorry, had to get a drink there, guys. My throat's a little bit sore. All right, another cutout. These are tough. So here we had a cone cut out of a cube. Here we have a cylinder cut out of a box. I'm going to do the same stuff I did last time. Maybe it helps it make sense, maybe not. I'm not sure. But I'm going to draw the net of the box. So if I draw the box, so we got this lateral surface. I'll make it a little bit longer. And let's say we cut it up into 4 spots. They do not have to be equal necessarily. I'm not going for some sort of prize here. And then we have something like this. There we go. And then we'd have the same thing over here. All right. So this would fold into the box. Now, when I get the surface area of the box, so my plan here is going to be to do the total of the box. Well, that is all of this. That's all of that. There's a problem. In this shape, the right side and the left side have circle-shaped holes. Circle-shaped holes. Those are not there. So on my net here, if I'm looking at the way it's folded, it would I think it'd be this side. It depends on how your perspective is. There's a circle-shaped hole on 2 of the faces. These are gone. That is not there. I have to subtract 2 circles to account for that. And then finally, what happened when I drill a hole, when I drill this cylinder out of this box, all the way through, there's an inside wall, right? Think about the roll of toilet paper we talked about. That's like where the cardboard would be. Could you see and paint this if you were holding this in your hand? It'd be on the inside, but is it a surface you could see? If you had a flashlight, could you shine your light and see this stuff on the inside? And the answer is yes. And that would be a rectangle. If you laid it out flat, the lateral of a cylinder would look like a rectangle, and we need to include that. So we're going to add the lateral of the cylinder. That's our plan. I know it's confusing. You just need to keep trying to get better at it. I honestly, like it's hard to explain. I don't know another way to explain it other than what I've said. And I wish I did, but I don't. But I'm going to go ahead and solve this problem. We're going to do pH plus 2b for the box minus 2 pi r squared for the circles plus 2 pi rh for the inside lateral surface. That's this in here. So for the box P, B, and H, you can pick whatever base you want. Let's see here. It says find the volume. The right and left side of the prism are squares. Okay, I was about to say we don't have information. Well, this is 7 and this is 7. If the right and left side are squares, those are both 7. And you can pick whatever you want to be the base. The general consensus is you pick the bottom to be the base. So if the height of the cylinder is 10, then this is going to be 10. So the perimeter, right? So I'm working on the bottom here. So we have 10 and 7. So that would be 17 times 2. The perimeter is 34. And the area is 70. And then how tall is it from the bottom to the top? It is 7. Over here, the radius they give you is 2. And the height that we need is 10. All right. So to finish the job, we do pH 34 times 7 plus 2b, 2 times 70, minus 2 pi times 2 squared, running out of room, plus 2 pi times 2 times 10. And just plugging in those numbers. So 34 times 7 plus 2 times 70, this is 378. Minus, this would be 4 times 2 minus 8 pi plus 40 pi. So it's 378 plus 32 pi. Type that in, 378 plus 32 pi. And I get 478.531. Nailed it. Perfect. Beautiful. All right, I need 1 second. I'm going to blow my nose, my friends. All right. Really sorry about that. Here we go. Going to go to the next one now. Number 4. Hold on, that's number 4. Can't even tell what number that is. Number 10. Linear dimensions of a rhombus are tripled. That's every dimension of the rhombus are tripled. That means D1 is tripled, D2 is tripled, everything is tripled. That means it's going to be times 3 squared. Remember, if all the dimensions are changed the same way, we square that number. If you write it down, if the original formula is D1 D2 over 2, and you triple that, that would be 3D1 times 3D2 over 2. Well, how many times are you multiplying by 3? It is twice. That's where the 3 squared comes in. All right. Number 11, what do we know? We know that the area ratio equals the similarity ratio squared. That's a rule we've talked about. And similarity ratio is any linear measurement. Length, width, height, depth, base, radius, circumference, perimeter, anything that's linear. And that would include this 6, and this 10. So we have a similarity ratio of 6 to 10, which reduces to 3/5. Height to height is my ratio. That is a common comparison. So the area ratio is going to equal 3/5 squared, which is 9/25. If I'm going to work with area, I have to use this ratio. So for this question, my goodness, nothing's working. So my pencil keeps disconnecting on me, and I don't know why. Actually, my whole iPad's frozen right now. I can't do a thing. Try to get back in. The whole thing's broken. Not sure why. Let me shake my iPad. I can't get it. Oh no, and it scrolled way down. I mean, I know I have a charge. I know it was plugged in. I guess I'll reconnect it manually and see if it likes that. I'm so sorry, guys. Pencil's done this a lot in class as well. But we're going to set up a proportion of 9/25. Maybe that gets it going. Apple Pencil, I see it. Oh, it does say it's dead. I've literally charged it all day. Okay, don't know what to tell you. 9/25, that's my area ratio, equals the area we want, right? That's the small shape over the area we have. Talked about reducing. 25 times 4 times 6 would be 1 and 24. So 9 times 24, 180 plus 36 is going to be 216. So that's how I would solve that, my friends. But the thing people forget to do is they forget to find the ratio of the areas, which is muy importante. We got to know how to do that. All right, pretty hard question here as well. Man, we're loaded. I love it. I actually love it. Key things you need to know about a problem like this that get a lot of people is that these two green lines are the same size. And we have a property here. So if I were to draw an isosceles triangle, we've learned this before. If I draw an isosceles triangle, if this is 120 and I drop a height, it cuts this side in half, right? If it's isosceles, it's an angle bisector. It's all those things. So this would become 60 and 60. Oh, man, I love this question a lot because now I have all these 30, 60, yes. But those are rules of isosceles triangles. Remember that a height on an isosceles triangle is also a median. It's also an angle bisector. So if they said find the area of the shaded region, the area of the circle is 144 pi. So let's back up. The area equals pi r squared for a circle. So 144 pi equals pi r squared. So the pi's cancel out. R squared equals 144. R is going to be 12. Well, that is 12 everywhere we see R. That is 12 everywhere we see R. Focus on our 30, 60, 90 rules. If that's 12, this would be 6, and this would be 6 root 3. So if I were to get the area of this triangle, right, this would be 6 root 3 as well. It'd be 1/2 times 12 root 3 times 6. Don't do half of half. Don't say half of 6 root 3. It's half of 12 root 3. Half of 12 root 3 times 6, which would be 36 root 3. So the triangle area is 36 root 3. The next thing we're going to have to do to get the area, it says what is the area of the shaded region? Well, I'm going to get all of this. This is called a sector of a circle, and I can get all of that. Remember that a sector of a circle, that the area is the measure out of 360 times pi r squared, right? It's the part you have out of 360. We have 1/3 of a circle times the original area, which would be pi times 12 squared, or they even told us it's 144 pi. So it's 1/3 of 144 pi. Now that does divide. Would that be 120? Would be 48. I think it's 48. Let me make sure. 144 divided by 3 is 48. So 48 pi is the area of this entire space. So what is the area of the shaded region? So the shaded region in blue would be the entire sector, 48 pi, minus the triangle, 36 root 3. And we're going to type that in. Hopefully we got the right answer. 48 pi minus 36 root 3. And I got 88.443. Oh, shoo, perfect. Got it. So that is number 12, looking great. Moving on. It says, in the following figure, Jorn's is a pentagon and RDAN is a parallelogram. The area of RDAN is 396. They gave us NA and angle RNA. Oh, that's the big deal. That's 120. We know that's 60. So I'm going to erase the 120, or I'll move it to another corner, 120 over here. We know it's the same size because this is going to be the key right here. I need this height. What did they tell me? They said NA is 12 root 3. So if that's 60, that would make this 30. So this would be 6 root 3. And this would be 18, 30, 60, 90 rules. 6 root 3 times root 3 is 6 times 3. That's got to be 18. Oh, this is a hard question. So what is the area of a parallelogram? Area equals base times height. This is for a parallelogram. We know that the area is 396, so we know that 396 equals the base times the height. Well, we know the height's 18. So 396 divided by 18 is 22. So the base equals 22. So this entire side is 22, which means this is 22. That's hard. That's the parallelogram part. Now we got to work on the pentagon part. Pentagon, like any other regular polygon, we're going to draw and use that right triangle, where this would be 11. I'm going to go do that work somewhere else. Over here, we have a side that's 11. Every pentagon, what do? We do 360 divided by, it's a pentagon, so we divide by 10, which would make this 36. We do our trig. This would be 11 over tan 36. So the area of the pentagon is 1/2 times base times height times 10 of them. So that would be 121. Be 121 with a 0 divided by 2. Oh gosh, that'd be 605 over tan 36. Let me make sure. 11 times 11 times 10 divided by 2 is 605. Perfect. And don't forget it's over tan 36. All right, so the question is, what percentage of the figure is the parallelogram? So remember what percent is. I know I'm running out of room here. Percent is the part you want out of the total times 100. The part we want, they gave us. The part we want is 396. What is the whole thing? The whole thing is the parallelogram plus the pentagon. Times 100. So that's my fraction. So I'm going to put that in my calculator. We have 396 over... And then the whole thing would be the parallelogram, 396, plus the pentagon, 605 over tan 36, times 100. I get 32.228. It says round to the nearest whole number, so we've got it. Perfect. All right. Looks like this is the last one. Man, having lots of fun here. Throat's hurting a little bit, but I'm having fun. Oh, yeah, this is a good one. So it says a pyramid has a base that's a 15gon. The base edges are 18, and the height of the pyramid is 9. What is the surface area of the pyramid? So visualizing is going to be pretty hard. So I'm going to go to the Google. And I'm going to search for just a pyramid. Wait, square pyramid. Was it a square pyramid? Oh no, let me go look. What was it? Oh no, it's a okay. Well, forget that. But I'm going to do a square pyramid and then we'll adjust. But I need you to understand some stuff. So I'm going to Google a square pyramid here. Oh yeah, look at these beautiful things. This is perfect. We'll take this one. And I'm going to copy that. And this is stuff you can do too when you're learning this stuff, guys. So I'm going to paste that in. So here's my square pyramid. Now this is not the pyramid we're working on, but we need to know a few things. It says the base edges are 18 and the height of the pyramid is 9. What is the surface area of the pyramid? So surface area of a pyramid is 1/2 PL plus B. We need P, we need B, and we need L. And I'm going to focus on the L part first. The L, so what do we have here? It says that the height is 9. This is not easy, my friends. The height starts at the apex and goes to the floor. The slant height starts at the apex and goes to the front door. And they're connected by the apothem. So we have a right triangle here where we know the height is 9, right? This would be the height over here. This would be my 9. And we need the apothem. We're going to have to get the apothem from the base. So the base is a regular 15-gon. It's not a square. If it was a square, like what is the base edge? The base edges are 18. If this was 18, then the apothem would be 9. But it's not a square. It's a 15-gon. So we need to do a whole nother problem, basically. And let's get that done. How do we work on a 15-gon? We draw a right triangle. We're going to do 360 divided by 30. There'd be 30 of these right triangles, right? I know this is a square, but this is the shape we're working on now. We're working on this right triangle that's on the base. And that's what we do for all polygons. So that would be 12 degrees. And if we know that the base edges are 18, this would be half a base edge. So the apothem is going to be 9 over the tangent of 12. So over here, the apothem, that's this line, that's going to be this line on this triangle, and this is hard. Visualizing this can be a little nuts. That's my apothem. That's the base of this triangle. This triangle that's inside the pyramid has a base that's the apothem, whereas this triangle that's on the bottom already, the apothem is over here. That's the left side of that triangle. So that's a tough go. Woo, boy. So now can we get the slant height? So the slant height would be this number, right? That would be this number. That's the hypotenuse. So the slant height equals the square root of 9 squared plus, use parentheses correctly, 9 over tangent 12 squared. So that's the slant height, and we're just going to leave that alone. Like, I'm not even going to type that in. Just going to leave it like that. All right. So that's going to be the square root of 9 squared plus 9 over tan 12 squared. Now let's work on the base. We need the perimeter. Well, if there's 15 sides and they're 18 each, can I just do 15 times 18? So the perimeter is going to be 270. And now I need the area, and that's where I got to work on this. So the area is going to be 1/2 times base times height times 30. There's 30 of these. So that would be 81 times 15 if you work those numbers. 810 plus 405, 1215 over tan 12. I'm going to type it in just to make sure. 9 times 9 times 30 divided by 2 is 1215. Perfect. And that's the area of the base. Remember, capital A, area, capital B means base area. So that's going to be 1215 over tangent 12. All right. I know. This is a tough question. The surface area equals 1/2 times the perimeter, 1/2 PL times the slant height. The slant height is the square root of 9 squared plus 9 over tangent 12, 9 over tangent 12. Squared. So that's 1/2 PL plus B plus 12/15 over tangent 12. That's my answer. I'm going to type that in, make sure hopefully that's right. We did a lot of work if that's wrong. So 1/2 times 270 times the square root of 9 squared. Make sure I do parentheses in my calculator of 9 over tangent 12, close parentheses, squared. Get out of the square root and add 12/15 over tan 12. And I get 11,559.953. Beautiful. Check mark. That's a monster. But we can do monsters. And I'm telling you, there are questions this hard coming up. So you're going to have to work really hard to understand them. I had a lot of fun doing this. I know these questions are challenging. I appreciate your effort. I appreciate all that you do to make sure that you do the best job you can. It means a lot to me. I'll see you guys next time.